going to be a rubber belt. It is reinforced with some other materials. It can be what we call a cog belt or square cut. Most of them are a cog belt. That just means these teeth are a little bit rounded on it. Versus this belt is an actual true square cut belt. This is usually older engines. Most engines use the cog belt with the slightly rounded teeth. So what's wrong with this picture? There's no teeth, right? We have a whole bunch of teeth that are missing right in a row. So that's one very common failure type for a timing belt. So over time, this belt gets brittle and basically there's some cracking behind those teeth, and eventually those teeth just start to come off. So sometimes it'll happen going down the road. Also, in my experience, I've seen this happen quite a few times where customers driving the car, everything's good, they shut it off, they go to start the engine back up. Well, when we go to start the engine, what are we actually trying to turn with the starter motor? The crankshaft, right? So we're trying to turn that crankshaft. From the crankshaft, we're relying on the belt to turn our camshaft or camshafts, right? And the camshafts are having to overcome all those valve springs. Well, what happens when we go to turn that crank sprocket just basically wipes out that section of teeth. And so the crank ends up turning, and what about the cam? It's just sitting there. So pistons are moving up and down, valves are not opening and closing. And there's another option for timing belt failure. So that one you see just basically ripped in half. So that happens sometimes too. So just a reminder, we've got a couple different options here. We could have a freewheeling or non-interference engine, where if the timing chain, timing belt, timing gears breaks, pistons and valves should not hit each other. So it'd just be a matter of putting a new belt on, and then we're good. Or we could have an interference or non-freewheeling design where pistons and valves will hit each other. So in that case, we could put a new belt on, but we still need new pistons and new valves, right? So generally speaking, if we have an interference engine and the belt or chain fails, what are we doing? Replacing the whole engine, right?
If manufacturers know that, why would they just make it all non-interference?
To make money.
That's a good question. So a couple different aspects of that. One is if you're a manufacturer, your end game is to make money, right? So it makes more sense to have an interference engine where you're going to be selling some engines. But really the biggest reason that this ends up happening, and the biggest reason why a lot of our engines are interference engines, is a lot of our engines have fairly high compression ratios, fairly large valves, fairly high valve lift in terms of how far that valve opens. So when you start to combine all those things and try to make the engine as compact as possible, a lot of our engines end up being interference. So during normal operation, everything's got clearance, but if something breaks, then you're going to have parts that are hitting each other.